right. Hello, everyone. My name is Jose Franco. I asked for the microphone because I move a lot, so. We're going to talk today about Arbitrum Stylus, and specifically, we're going to talk how to upgrade a contract that is written in Solidity to a Rust contract, right? Through proxies. Then first of all, my name is Jose Franco. I'm an integration engineer at Off-Chain Labs. Here are my Twitter and Telegram handles. I don't write a lot on Twitter, but you can contact me there, and Telegram, of course. And Off-Chain Labs, well, we are the initial builders of Arbitrum 1 and Nova before they were transferred to the Arbitrum DAO. And we are the developers of Stylus and Orbit. So for these hackathons, we have specific price tracks for Stylus and Orbit. If you want to know more about specifically Orbit, we are going to learn about Stylus today. Just go to our booth and we'll be more than happy to help you. All right, this workshop is divided into two parts. The first one is just an introduction to Stylus. We're going to talk about what it is, what it enables, and what benefits it has. And then we're going to show a simple counter contract written in Rust, right? And the second one is a bit more advanced. And we're going to talk about how to upgrade this Solidity contract that you have behind the proxy to a Rust contract, what you have to keep in mind when you do that, right? And we will also see a sample project. So first of all, what is Stylus? Stylus is an upgrade to the current development environment we have for smart contracts on EVM chains, right? What that means is that if you want to write a smart contract today, on an EVM chain, usually write that in Solidity or in Viper as well, right? But that's your choice. That's what you have to. That's the choice that you have, right? So Stylus, what it allows you is to write smart contracts in other languages like Rust, C, C++, and many other languages that will be interoperate with the EVM as well. I mean, so. The way this works is that Stylus activates a new virtual machine, different than the EVM, that executes WASM bytecode, right? And that virtual machine lives alongside the EVM, and they can talk to each other, right? So if you have a Stylus smart contract, it is executed in the WASM virtual machine, but you can, from there, you can call Solidity contracts that are executed in the EVM machine, and the other way around, okay? They are fully interoperable. One of the main benefits that Stylus brings is that we can access new developers' ecosystems, right? Like the Rust one or the C++ one. And these are all numbers. This is from 2022, almost 2 years ago. But probably the numbers have changed, but the ratios are probably the same. So we are now opening the development space to new communities as well, right? So more benefits from Stylus. It increases speed and reduces cost. This is generally true because WASM bytecode is going to be more efficient than Solidity bytecode. Then you have to take into consideration storage accesses and all that. But generally speaking, it is more efficient. And then also big improvement in memory usage that brings also new use cases like advanced cryptography, generative art. I was talking with a colleague yesterday, and they were able to implement this Black-Scholes algorithm that is used in finance, for example, that is very complex to do in Solidity because, yeah, you end up with transactions that spend a lot of gas. You can do that with Stylus now, and it reduces a lot the usage of gas, and those are, yeah, a few examples of what you can do. So what we have today is that besides the virtual machine, we are also building an SDK for Rust. There is another one for C and C++. We are putting more effort into Rust, so the SDK is more advanced. But actually, you don't need an SDK to write your smart contract because any language that can be compiled to WASM can use Arbitrum Stylus. And actually, we have examples of smart contracts written in Zig and assembly script. They don't use any SDK or anything. It's just a program that is compiled to WASM, it is deployed on chain, and yeah, you run it. That's it. So the next steps for Stylus and the current state, actually, we have enabled Stylus in Arbitrum Sepolia. So today you can deploy your Stylus programs there and run them. And there is an AIP already in the governance forum to activate it on Arbitrum 1 and Nova. The on-chain vote will come soon. I don't know exactly when, but probably soon. And if the DAO vote for it, we will enable that on 1 and Nova. All right. These are 3 resources that I like to share with people who want to start with Stylus. Don't worry about searching for these, because at the end of the presentation, I'm going to show you a QR code that has all these resources, all right? So the first one is a quick start. This is in the public documentation. It goes through how to set up your environment and how to work with a Hello World contract that is written in Rust, how to deploy it, how to use the Cargo Stylus tool that we use for that. Then we have the Stylus by example. That's another different portal that contains information about how you can do certain things with using the Rust SDK. For example, how do you emit a log? How do you handle errors? How do you, I don't know, encode function selectors, stuff like that, all right? And finally, Awesome Stylus is a repository of code that's been written by third-party developers, and we maintain there, so you guys have examples of things that you can do with Stylus, right? All right, so first example. This is a basic counter contract. It just has one variable that is a counter. You can increment it. You can change. You can set a different count and all that. So this is a perfect example to see for a Rust smart contract. We are going to take a look at it now. All right, here it is. So for those of you who are familiar with Rust, you will see that this structure that we have here is similar to what you get when you create a new cargo project. Actually, the projects for Stylus are created with cargo. So we have our SRC folder, and we have a main file and a leave file. The main file, we usually only use it to be able to export the ABI of the contract that we're going to write, right? So the main entry point for the contract and the main file that contains the contract code is the lib file. And in here, this contract is very basic. It only, well, it's called a counter. It only has one storage variable. I'm going to explain this now. And these 3 functions, get, set, count, and increment, right? Okay, so I'm going to explain these things by explaining what specific Stylus macros we have here. And the first one that we have is this Solidity storage macro. And this macro tells Stylus that the next struct that it's going to find defines the storage layout that our contract is going to have, right? So in this case, we only have one variable, one U256 variable named count, and that's it. The next one that we have is entry point. Entry point defines, well, tells Stylus where the execution of the smart contract begins. That means that if whenever you call this contract, you are telling Stylus, hey, whenever you receive a transaction, you start executing code from here on, right? So usually these 2 macros go together, Solidity storage and entry point. The last one that we have here is external. External tells Stylus that the next functions that it's going to find are public functions. They can be called from outside the contract, right? If you want to implement any private contract, you can do so by adding another impl counter above the external macro, and those will be internal, right? Okay, and as I said, these 3 functions, well, the get function only returns the count. The set count sets a different count, a different number in the variable, and increment, well, increments by 1. Another thing to keep in mind here is that when building the Stylus, when we compile the Rust code into WASM, we change the code and we change the function so they are Solidity ABI compatible, okay? What this means is that we want users to not care about what language the contract is written in, but we want them to be able to call them the same way they call Solidity contracts, right? So for example, we have here a set count function that is using Rust syntax. It's using snake case, right? But this is not the way Solidity ABI functions are written, right? So when compiling this program, the SDK is going to change this. So when you call this function, you will have to use camel case, the same way you do with Solidity, all right? And that being said, I think we have time to quickly run this example. We have this, I can answer questions later, okay? We have also this script folder that holds, scripts to perform individual operations. So if we call, for example, the deploy function here, the deploy script, need to go to scripts, deploy. It's going to deploy our program. We can take a look at it. It actually uses the cargo Stylus tool. I don't want to go into details about this, but you have that in the documentation. And then, so our contract is now deployed to this address. And we can, for example, get count here. I have this comment to help me with this. We get the count. The counter is 0, obviously, because we just deployed the program. We increment it. Yeah, okay, and then we get the count again, and it's 1. So as you can see here, we are using actually Foundry cast to call our Stylus program, the same way you would call a Solidity program, right? And if we go to the set count script, it's using cast send, and as I said before, it's using set count in camel case, okay? So this is going to be important for what we're going to see later. All right, let's go back to the presentation here. All right, let's go to the second part. Now, I'm going to talk a bit about upgradability of smart contracts. You probably know everything about proxies and all that, but in case anyone hasn't worked with proxies, let me just cover the basics to understand what we're going to do later. So as you know, smart contracts are immutable. That means that when you deploy the bytecode, you cannot modify it, right? But obviously, sometimes you want to have upgradable smart contracts because you want to be able to fix bugs. You want to be able to improve the logic of your contract. So how do you obtain upgradability? Well, one of the most common patterns that we use are proxies, okay? And proxies are just smart contracts that are deployed in front of a logic contract, of the contract that has the business logic of your application. So let's say that, for example, you want to have you want to deploy an ERC20 contract that is upgradable. You deploy the ERC20 contract, and in front of it, you deploy the proxy. Your users are going to call the proxy. They are only going to interact with the proxy. And that contract is going to delegate call the ERC20 contract. Then if you want to upgrade the logic, you just deploy a new ERC20 and point the proxy to that one. So whenever the users call the proxy contract, the call will be forwarded to the new logic contract. Then what happened with the storage? Because we are delegate calling from the proxy, we are using the storage space of the proxy contract, right? And this is important because otherwise we will use the storage space of the logic contract, and if we change it, well, we lose all the information, right? So one thing to keep in mind when upgrading is that you need to keep the same storage layout as the previous logic contract. Otherwise, you will be messing with the slots, and I don't know, if you change the balances mapping with the owner's mapping, you might be asking for the wrong information later, all right? However, you can extend it. If you keep the same storage layout and you add new variables below, you can extend it, and yeah, just keep in mind that for the next one, you have to keep the same storage layout. And the other thing to keep in mind is that logic contracts shouldn't be initialized with a constructor, because if we are modifying the storage in the logic contract directly, we are not modifying the storage from the proxy, right? So what we usually do is that we initialize the contract. I don't know, in the case of an ERC20, we set the name and the symbols, for example, from a special initialization function that we call from the proxy. So Oh yeah, one thing to keep in mind is that I'm giving a very basic explanation of proxies. So proxies are very complex and can do a lot of things. This is just the basics to see what we are going to see today. There is a lot of information on Google. I'm more than happy to talk about proxies as well, but yeah, just keep in mind that these are much more complex. So requirements of the proxy pattern that we are going to use. The logic contracts, these ERC20 contracts, need to be initialized from the proxy or through the proxy, not with constructor, and we need to keep the same storage layout when we upgrade the logic contract, right? All right, so let's get to it then. We're going to upgrade a Solidity ERC20 contract to a Rust implementation. This Solidity ERC20 contract is going to be behind the proxy, right? So the steps that we are going to follow more or less are, first, we are going to replicate the storage layout in the Rust contract. Second, we're going to write the same contract functions in the Rust contract. We can modify the logic if we need, but the signatures have to be the same. And then to test, we are going to simulate the update flow and add any necessary functionality we need there. All right, so for the Solidity part of this code sample, we are going to use OpenZeppelin's library, right? So for the proxy, we are just using a transparent upgradable proxy, just simple as that. For the ERC20 contract, we are going to use their implementation. We are using here the standard, the non-upgradable implementation. They have an upgradable implementation for the ERC20, but we want to keep the storage as simple as possible. The upgradable uses a specific storage slot. We want to start the storage slot in the slot 0 or whatever the slot we start from. And we are also using the initializable library to be able to initialize the contract through the proxy, right? So one thing to keep in mind here is that the initializable contract, when you inherit from it, you are adding two storage variables, two special storage variables to your contract, right? And because we are inheriting from that one before the ERC20, we are going to have those two storage variables first, and then we will have all the storage variables for the ERC20 contract. We need to keep that in mind when we build our Rust contract. And then we have just the initialize function. I'm not initializing the token name and symbol here. I'm just hard coding those values because I want to make this simple. And we have one mint function. All right, so let's move to Rust then. When we write our Rust smart contract, the first thing we are going to do is to replicate our storage layout. And here I want to show you a different macro that we can use as well, which is sol storage. This one is different than the previous one. The previous one was Solidity storage, and this is sol storage. The difference between those is the syntax that you are going to use for your variables, right? So for the previous one, we use Rust syntax, and for this one, we are using Solidity syntax. This is interesting, especially for these use cases, because if you are familiar with Solidity, if you are a Solidity developer, it's very easy to copy the storage layout that you have and paste it as is in your Rust smart contract. If you are a Rust developer and you don't know anything about Solidity, it doesn't matter, you just write with Rust syntax. Okay, and here we are using also a borrow macro, because in this specific example, we have our ERC20 implementation is in a different file. I wanted to show you a more complex example. So in this case, everything that is ERC20 is in a different file, and then we call that module from our first lib module. We will see that in the code later. Yeah, so then we're going to write the same functions in our Rust contract. We are using another special macro here, this inherit macro, that is going to take all the functions that we have in this ERC20 module, and they are going to add it to my token. We are adding a new burn function here that we didn't have in the Solidity contract. Yeah, that's it. So 3 contracts, Proxy and ERC20 in Solidity. Those are going to be deployed with Foundry. And then we have the Rust contract, the ERC20 Rust contract, that later we're going to deploy and change the proxy contract to point on that one. All right, so let's take a quick look at it. Ooh, bad time to be signed out. It is this one, yeah. So this is the QR code that I'm going to show at the end. Is for this repository. The README of this repository contains all these resources that I talked about before. In this project, we have 3 main folders. We have the proxy, which is just a Foundry project that contains the proxy code. Then we have the ERC20 Solidity that contains my token, similar to what we saw before, but with a few things. I had to add a constructor here, even though it doesn't do anything, because I'm not using the upgradable. And yeah, OpenZeppelin requires to have the constructor. The initialize that we saw before, the mint, and the hard-coded name and symbol. And then we have the Rust contract here. So the Rust contract has the main file, the same as before, just to export the ABI. And then we have the lib and the ERC20. The ERC20 has what I said before, the implementation of the ERC20 standard, right? It uses the Sol storage that handles Solidity syntax. So it has balances, allowances, total supply. Then we have our events and errors that we can emit and throw. And then in here, we have an impl of the ERC20 that doesn't have the external macro that we saw before. That means that these functions are internal. They can only be called from within the contract, right? We have our transfer, we have our mint, burn, all the internal functions that we need. And then we have a different impl, ERC20, with the external macro. So these are the functions that we can call from outside the contract, right? The name, symbol, decimals, total supply, well, everything that we need. So notice that even though in Solidity we have transfer from in camel case, here we are writing in snake case because we're writing our Rust contract. So this is going to be compiled to WASM. It's going to change the way we call it. So it's going to be compatible with the proxy that we are using, okay? Users are not going to notice any difference there. All right, so from the lib file, in the end, the lib, remember, is the entry point for our contract. So even though we have the ERC20 file, all calls are going to go through whatever we have in lib first, right? We are using the ERC20 module that we just saw. The Sol storage is what we saw before. Remember that we had two variables, two storage variables that come from the initializable contract. And so we are putting them first, and then we are borrowing the ones from the ERC20 module. And we have the mint function and the burn function that we are adding, all right? I think we can do a quick test here. For the scripts folder, we have the same thing here. If you want to run it, we can just deploy it. One test that I like to do, let's see if I can do everything with one hand. Deploy. So deploy, it's only going to deploy the Solidity contracts. All right, so we have the proxy here. We will need both the proxy contract and admin for later, but for now, let's get the token information here. Let's see. All right, so let's get the token information. Let's mint some tokens. Yeah. I'm not sure I have time for the full demo, but let's try. Yeah, And let's get the balance. All right. So here for the balance, I'm just using the deployer account. All right. And now what we are going to do, if I can, is to upgrade the contract with the update logic script. For this one, we need the proxy contract and the proxy admin, because we need to send the update call from the proxy admin address, right? Copy and so this is going to deploy the Rust contract using cargo Stylus, and then it's going to call the update function of the proxy contract. So now, if we go to the get information, we'll see that we have now the my token v2, so it's using the contract, the Rust contract, and if we go to balance, we should have the same balance as we had before. So the first that were minted on initialization, and the last 100 tokens that we minted with this. All right, so I don't have more time, so I will just show you the QR code. If this allows me to show you the QR code. Ah, no. Well, I'm going to, yeah, I'll do another thing. I'll write on Discord on the ETHGlobal server. I will send this presentation. I will send you the link to the repository actually that contains everything. And yeah, you can grab it from there, okay? I will send it in the partner Arbitrum channel of the ETHGlobal Discord. And yeah, thank you very much. I don't know, I think someone had a question before. I have 1 minute left. Yeah.
First, you have your own implementations of ARC and not something like Open Zeppelin library
For Stylus?
For Stylus, yes, for Rust or C++?
I think they are working on a library for Rust contracts. I can try to dig in some information and see what I can find. I think they actually publish it on Twitter, I think, if I remember correctly.
Okay. The second question is, so there's these getter functions. So does your compiler understand that this Rust code does not change anything since hence it's a view function? Or is there a way that I mark the function as view, for example?
Oh, I see what you mean. I'm not 100% sure, but I believe if you don't modify the storage, it's just going to mark it as viewer. Yeah, it should. The SDK, the Rust SDK.
Rust understands if I'm modifying a variable or not. So
yeah, so the SDK probably when it compiles it to WASM, it will just mark it as view.
Okay. Do I get to? Is there syntax similar to modifiers or?
Yeah, well, actually what you can do is that, well, we had several macros that you can use and you put them in top of the function and then give you, for example, for a payable modifier, we had a payable macro and you put it on top of your function and then it makes it payable, for example.
Okay,
all right.
Somehow I can use similar macro that say, again, modifier, for example.
Oh, you mean for modifiers? Yeah. Okay. Sorry.
If owner, for example.
Yeah, I don't know. I can find that out, but yeah, but I don't know if you have the same behavior as modifiers in Rust.
So it will ultimately be API compatible with Solidity.
Yeah, the same.
I can write, if I can write that code specifically at the start.
Yeah, exactly.
But I still want to be compatible with Solidity APIs, like you mentioned.
Yeah, it's going to be compatible with Solidity APIs. If you want, because I ran out of time, if you want, we can talk about it in our booth. I don't know if we have time. No. Okay. So yeah.
If there are questions, they can go with you to the booth.
Yeah, exactly. You can go to our booth and we will talk, or even outside here. Thank you very much.